What precisely lies at the edge of the discernible universe has stayed a secret for quite a long time, energizing interest and theory among researchers and lovers alike. Anyway, the James Webb Space Telescope holds the key to uncovering this astronomical mystery with its powerful instruments, looking further into space. It has recently made a momentous declaration about what lies at the edge of the visible universe. When we discuss the edge of the universe, it's fundamental to understand the concept of the perceptible universe. The recognizable universe includes all that we can see, measure, and study from Earth or our space-based telescopes and exploratory tests. Right now, it comprises stars, systems, and other divine objects that are within our observational reach. So, what's the distinction between the universe with a capital U and the perceptible universe? In simple terms, the perceptible universe is just a small part of the whole universe that we can study and appreciate. While the total size and state of the whole universe are obscure, there is an estimated diameter of the recognizable universe, which is around 93 billion light-years. A light-year is a unit of distance that light travels in 1 year, which is approximately 5.88 trillion miles or 9.46 trillion kilometers. Thus, the measurement of the recognizable universe, 93 billion light-years, is an unbelievably immense region, spreading over around 546 million light-years. The theory of how things came to be tells us that around 13.8 billion years ago, the universe was brought into existence in a powerful explosion. This hazardous event set off a rapid development, and from that point forward, the universe has been expanding at an increasingly quicker speed, driven by baffling forces like dark energy. As the universe expanded, particles of matter began grouping together due to the power of gravity, forming moving designs like stars, galaxies, and, eventually, even planets like our beloved Earth. Over countless years, these infinite designs became larger and more complex, leading to the phenomenal variety of objects and phenomena that we observe throughout the universe today. In spite of the boundlessness of the universe, it is predominantly void. To put it in perspective, if we downsize our entire planetary system to the size of a quarter, the closest star would still be the distance of 2 soccer fields away. This is just within our Milky Way galaxy, which is one among billions in the perceptible universe. You might ask why we can't see the whole universe. There are 2 realities that explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we are, in reality, observing them as they were in the past. The farther away an object is, the longer its light takes to reach us, so by observing distant galaxies, we are essentially looking back in time, unraveling the history of our universe. The second explanation involves the universe's expansion. Imagine dots on the surface of a swelling inflatable. As the balloon expands, the dots move away from each other. A similar principle applies to the universe, where galaxies are drifting apart as space itself expands. This expansion causes the light from distant objects to become stretched, shifting toward longer wavelengths, which we observe as redshift. Eventually, some objects will move beyond our observational reach as they retreat past a certain distance. Considering these factors, it's not surprising that we haven't seen the whole universe. However, the concept of the edge of the universe is a marvelous subject that has fascinated researchers, scholars, and thinkers for ages. We have a wide range of hypotheses about what lies beyond. However, the reality remains slippery. Nonetheless, there are 3 prominent theories that stand out. The first theory posits that the universe continues indefinitely in sight. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning that it appears the same in every direction. If this principle holds true, it suggests that the universe extends on perpetually without a limit. The second theory suggests that the universe is finite but doesn't have a clear edge. This means it's like a giant sphere, and if you keep going in any direction, you'll eventually circle back to where you started. The third theory is the multiverse hypothesis, which suggests that our universe is just one of many. Imagine a multitude of parallel universes, each with its own set of rules and properties. These universes could be completely different from one another or somehow connected. Having discussed ideas surrounding the edge of the universe and examined various hypotheses, we should now focus on a remarkable tool that holds the potential to shed light on these mysteries: The James Webb Space Telescope, JWST. This astounding telescope allows us to look far back in time and discover unseen objects from the dawn of the universe. The JWST, with its advanced capabilities, has empowered cosmologists to peer back into the beginning of the universe and consider what they have stumbled upon. In a recent study published in the journal Nature, the JWST found 6 gigantic galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only hoping to find small, newly formed galaxies, yet the JWST caught them off guard. These galaxies are much larger than anyone ever imagined, challenging what we assumed we knew about the early universe. However, that's not all. Scientists also found something incredible. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. The mass of stars within each of these objects totals several billion times larger than that of our Sun. According to the research, one of them in particular may be as much as 100 times our Sun's mass. For comparison, the Milky Way contains a mass of stars comparable to approximately 60 billion suns. You see, this telescope has an exceptional power. It can see things that are invisible to our eyes. By utilizing infrared light, it captures the faint glow from ancient stars and galaxies that have existed for billions of years. This means the JWST can literally take us back in time, providing a glimpse of what the universe looked like around 13.5 billion years ago. Now, here's where it gets really interesting. The universe is estimated to be around 13.7 billion years old, so this discovery has flipped things around. It's like rewriting the history books. These enormous galaxies, nicknamed universe breakers, have scientists scratching their heads. They defy the majority of the models we had for early galaxies. We used to think galaxies began as small clouds of stars and dust, gradually growing over time. Well, these universe breakers have discredited us. When the JWST's data and high-resolution photographs opened up in July 2022, specialists were blown away. They were shocked when they saw these galaxies as huge points of light, questioning their own understanding of the data. The sudden appearance of these massive objects, as if they needed to be found, astonished everyone. By utilizing spectroscopic methods to analyze light across various frequencies, researchers can uncover important data about these galaxies, such as their structure, size, and distance from Earth. What's interesting is that this notable discovery wasn't even at the top of the list of things researchers had characterized with the James Webb Telescope. It surpassed all expectations and unfurled much faster than anticipated. There's even a possibility that some of the objects found using JWST data might be something entirely different. While most are likely galaxies, it's possible that a few could be hidden supermassive black holes. Here's the fascinating part. The known mass of stars in the universe is now believed to ultimately depend on many more times than we previously thought. This discovery is still remarkable, even if we consider only half of the sample. Meanwhile, utilizing the powerful James Webb Space Telescope, a global team of space experts also made an incredible revelation. They found the oldest and farthest galaxies ever confirmed. These galaxies take us back to when the universe was merely a fraction of its current age, less than 400 million years after the Big Bang. The light from these galaxies reached us more than 13.4 billion years ago, as confirmed by the telescope. Like the early observations made by the Hubble Space Telescope, the initial images captured by the JWST revealed various potential galaxies. Now, through meticulous spectroscopic observations, astronomers have confirmed 4 of these objects, allowing them not only to study the actual properties of the galaxies, but also to accurately determine their distances. To determine a galaxy's distance, astronomers compute its redshift. Redshift is a phenomenon where objects appear to move away from us, causing their light to stretch and shift toward longer, redder wavelengths as the universe expands. Redshift measurements can be obtained from photographs taken through different filters. However, spectroscopy is the preferred method for acquiring precise measurements, as it separates the object's light into its constituent frequencies. The new discoveries focus on 4 galaxies with redshifts greater than 10. They are truly far away. The Hubble Space Telescope had previously spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. However, the JWST images revealed two even more distant galaxies with redshifts of 13.10 and 12.63. A redshift of 13.10 indicates a time period of approximately 13.5 billion years ago, unveiling ancient cosmic history. Additionally, the JWST's Advanced Deep Extragalactic Survey, JADES, is an ambitious program that has been allocated over a month of the telescope's time. Its goal is to provide an exceptional look into the early universe. In 2015, a consortium of instrument teams proposed this project, forming a global collaboration known as JADES, involving more than 80 astronomers and researchers from 10 different countries. Beginning with an emphasis on the JADES program, the telescope dedicated over 10 hours of mission time to observing a small area of the sky, including the Hubble Extreme Deep Field, XDF, a small region in the southern sky. This survey revealed an incredible depth of light from various sources, shedding light on more than 250,000 galaxies in a very small portion of the universe. The telescope took pictures across 4 wavelengths of light, observing an immense amount of light originating from distant galaxies, providing vital data to understand the universe's past. So, where does this leave us? The James Webb Space Telescope is genuinely changing the way we understand our universe. It is like a time machine, taking us back to an era when galaxies were in their infancy. As we gather more data and understand what lies beyond our perceptible universe, we may start unraveling the mysteries of what exists at the edges of space and time. Although we may never have definitive answers, these discoveries might lead to profound insights about the nature of reality and our place in the universe. The edge of the universe remains an alluring enigma that will continue to inspire curiosity and exploration for generations to come.